Okay, second question. If two resistors with resistance R1 and R2, okay, R1 and R2, and they are connected in parallel, then the total resistance R, okay, it follows this formula. So 1 over R is equal to 1 over R1 plus 1 over R2. Okay, R1, R2 are two resistors, okay, and the total resistance is R. Okay, so now if R1 and R2 are increasing at the rate of 0.3 and 0.2 respectively, okay, so we already know R1 is increasing at 0.3. So dR1 over dt is 0.3. Again, R1 is a resistance, T is a time. Okay, dR2 over dt, it is 0.2. Okay, then how fast is R changing when R1 is 80 and R2 is 100? Okay, so you already know R1 and R2, and you already know their rates of change, and you want to know R's rate of change. Okay, you want to know R's rate of change. So you want to know what is dR over dt. Okay, so now the equation connecting R with R1 and R2 is already given. Okay, so what we do is we differentiate both sides. Okay, let's do it here. We differentiate both sides by t. Okay, so differentiate the left by t is equal to you differentiate the right-hand side by t. Okay, here is a very important thing. You need to realize that R, R1, R2, and R, they are all functions. Okay, they are all functions of t. Okay, for example, we don't know what function is it. For example, R, it could be maybe t squared times sine t. Okay, it's just something random. It's not true. R could be, okay, R could be maybe t, like 2t plus 3. It doesn't matter. But essentially, R is a function of t. Okay, and you don't know the expression. You don't know the expression. Then when we differentiate the left-hand side, we need to use a chain rule. Okay, first it's 1 over something, right? Remember, 1 over x, the derivative is negative 1 over x squared. This is because it's x to the power of negative 1's derivative. First, you bring the power down, you have a negative 1, and then x to the power of negative 1 minus 1, it's negative 2. So here, the left-hand side is negative 1 over r squared. Okay, and don't forget, R2, R is a function of t, so you have to further differentiate dr over dt. Okay, dr over dt. And the right-hand side is the same, so 1 over r1, the derivative is just negative 1 over r1 squared. Okay, times r1 is a function, r1 is a function of t, right? R1 is a function of t, so times dr1 over dt. And same thing, 1 over R2 times dR2 over dt. Okay, so now let's sub in. All right, the right-hand side, we know everything. Okay, from here, we can see R1, R2, dR1, dR2, they're all given. So it's negative 1 over 80 squared, right, times 0.3, minus 1 over 100 squared, times 0.2. Okay, the left-hand side, this is what we want to know, but this we don't know. Okay, how do we get R? Right, we still have this formula. Right, so 1 over R1, let's do it here. Okay, because 1 over R1 plus 1 over R2 is 1 over R. Okay, so here it's 1 over 80 plus 1 over 100 is 1 over R. Okay, that's why R is 400 over 9. Okay, you do the calculation, you get 400 over 9. So here, let's sub R in. So it's 1 over 400 over 9 square, okay, negative, times dr over dt is equal to the right-hand side. Then you just use your calculator, get the solution. Okay, so dr over dt is around 0.132. All right, sorry, here it's a typo. It should be has a square here. Okay. And that will be all for this question.